say about a project that we did with AWD today up in Granton-on-Spey, a bit of a bridge analysis for a temporary deck. And then I'm going to kind of build on my presentation from Willesden earlier in the year, which was based on kind of pre-weakening works for a crane. I'm going to kind of do some general overviews of kind of pre-weakening cuts and how they work. So just to give you a brief overview, I'm sure a lot of you have seen these before, but hopefully you can hear us. We can't hear you. And if you would like to ask questions, please use the Q&A button at the bottom. And we will try and run through as many questions as possible at the end. So moving swiftly on. So bridge at Granton-on-Spey. So our scope here was to check this bridge for the temporary deck loads to carry out some repairs to the concrete arches. The deck was going to be underslung on the bridge and hung off it. And the bridge was to remain completely open during the works and subject to kind of quite high HB loading. The bridge itself is surprisingly pretty for a reinforced concrete bridge. It spans about 73 meters, obviously over the River Spey. As far as historical information was concerned, we actually had quite good information. It's a 3-pin arch. So I've not got the pointer up, but you can see that you've got a pin at mid-span and a pin at both abutments there. And it's formed of 4 ribs with beams in between to prevent any kind of lateral torsional buckling. It was built in 1930s, so it's quite early reinforced concrete, and there is a fair amount of reinforcement in the actual beams, as you can see from the little screenshot I've taken there. The bridge deck itself had been strengthened in the past. In 1998, they'd added another reinforced concrete deck on top of the original one, and they'd also added some extra diaphragms around that central pin because they had become degraded over time. The work they were doing this time around was kind of repairing the spalling that occurred on the bridge beams over the past 20 odd years, I guess now. And that was why we were involved in the project. So just have a look at some of the load cases we considered. So top left is kind of looking at the self-weight of the bridge itself. We carried out a kind of a load takedown from all of the columns of the bridge. And then you can see in the central section where the bridge bears directly onto the arches themselves. We've taken that load as a UDL. The top right image shows the imposed loads from the temporary deck. These were provided by the actual deck supplier himself, and they were generally quite uniform. There were some extra loads at either end where they were building multiple layers of the decks inside the bridge, kind of to do some repairs to the columns within the bridge itself. And the bottom two just show some of the load cases we took in conjunction. So looking at big HB loads at mid-span and at quarter span of the bridge, just to observe how they reacted with the extra deck loads. So moving on to the moment diagram. So actually under self-weight, these beams went into a bit of hogging, which was quite interesting. As you can see there with the HB load at mid-span, you've got significant hogging in both sides of the arch due to those loads, and the deck loads marginally increase this hogging. With the HB load at quarter span, you can see obviously the beam goes into sagging where the load is, but the use of the deck there actually reduced this moment because the deck itself causes hogging in the beams. So this was a fairly good project for this. Worked in collaboration with AWD on the project, and yeah, I've seen pictures recently. The deck is up and in place, and they are carrying out the works at the moment. So moving on to pre-weakening cuts. So I did a bit on this in the Willesden project. I think it's one of the first presentations we did this year. This is more of a general overview of what you're looking to achieve when you're carrying out kind of pre-weakening works. So this is a fairly basic column cut. What you're looking for here is to obviously maintain stability of the structure while being able to then form a hinge when you kind of impose a destabilizing force on the column. So in this situation, the pull down or blow down will be conducted from right to left. So once you start the collapse, you'll form a hinge at that right-hand flange, and the shims shown green here will fall away. These kind of cuts Obviously, you've got to maintain the stability which is provided by the self-weight of the structure and prevent any kind of wind loading or notional loads destabilizing it prior to the pull down itself. If there are high shear loads, you can also look at kind of both sloping or castle cuts to help resist these. Moving on to beams, so where you're kind of pulling a structure away from a remaining section of structure or pulling it down in sections, you'll quite often use these kind of beam cuts. These are the kind of bog standard basic cuts. You've got your sit cut on the left, where you've got a cut and then the beam sits on the web of the remaining bit of the structure, and a sloping cut, which is similar but provides far less restraint. So these, when you initiate the pull down, it's the same here, from right to left, the beams would come free of the remaining structure, and you were done. You'd get your pull down, and you just have to overcome the frictional forces at each of the cuts. If you're looking for further restraint or due to the imposed loads on the structure, you can obviously use tabs, leave these tabs in place prior to the pull down. These will be broken when you initiate it, or you can kind of, and also in plan, you can obviously use V cuts or castle cuts as well to prevent lateral movement in the structure prior to the pull down, but not prevent the actual collapse of the structure itself. So that is kind of a basic overview of kind of your pre-weakening cuts that you can use. It's just to give a bit of an overview of some of the projects that we've worked on this year without mentioning names. So I will now hand over to Richard, who's going to chat about some bridge demo, I think.